Hi, I'm Andrew, and this is Victoria from Optilab, here today to demonstrate our 40-kilometer distributed fiber Bragg grading sensing system without the use of any repeaters or amplifiers. Optilab has three unique interrogators, including our 1U rack mount, aerospace module, and outdoor unit. To accurately monitor the structural health of 40 kilometers of an oil pipeline using distributed FBG sensing, you are faced with a large amount of sensors, lots of data to process, large propagation loss, and location-specific time delay. To overcome these issues, Optilab FSI utilizes digital signal processing DSP technology for high-speed, high-resolution detection. The FSI's DSP enables FFT, which reduces data traffic and post-data processing. In addition, our unique design utilizes high dynamic range and channel-specific delay time compensation. If we look at the schematic, each channel monitors 6 FPGs covering 0.6 kilometers. Each interrogator covers 10.8 kilometers with a total sensor distribution range of 43.2 kilometers. Interrogator number 4, covering the last 10 kilometers, will use a high optical power design. Due to time limitations today, for our demonstration, we are presenting the last 5 kilometers of our high power system. We are remotely connected to the computer used to monitor the FSI and have a live video feed from our setup as well. Dr. Yin is also with us today via live video in our headquarters in Phoenix, Arizona. So if we look at the video over here, to the left over here we have our FSI. 9 of these channels are connected to these 35 to 40 kilometer fiber spools. These spools are then connected to these 9 FPG test beds. The other 9 channels of the FSI are connected directly to the 9 FPG test beds. And FPG test bed number 1 is connected in series to a tunable FPG, which is then connected in series to an FPG mounted pendulum. Now if we enter the time domain section of our software and we look at the y-axis, we have our wavelength values. Each line represents an FPG sensor. As you can see, as Victoria toggles through the different channels, all FPGs within each channels are displayed at their proper wavelengths. So if we go back to channel 1, remote connection kind of lag. And we zoom to those additional 2 FPGs in the center. The top line is the tunable FPG, and the bottom line is the FPG pendulum. Dr. Yin is going to input a sine wave into the tunable FPG. Let's see what happens. You can see the wavelength in the sine function. Now if he changes the frequency of the sine wave, you can see the change in the measurement. Now if we look at the bottom line, let's see what happens if Dr. Yin oscillates the pendulum. You can see the FPG captures the pendulum motion. Now remember, this is almost an instantaneous change you are seeing when the interrogator could be located here in Palo Alto while the sensor would be past the San Francisco International Airport up to 25 miles away. Now if we go to the FFT section of our software and have the proper channel selected for the gauge ID and proper channel and gauge ID selected, you will see that the tunable FPG, you will see 172 hertz. The tunable FPG is centered at 172 hertz. Now Dr. Yin will put the tunable FPG into sweep mode, and you can see as he does that, the amplitude sweep over the frequency, reaching a peak at its resonance frequency, 172 hertz. For some reason it's not working. So if we look at the pendulum, when Leijing oscillates, I'll switch back now. Now if we go to the pendulum gauge, when Leijing oscillates the pendulum, it peaks and dampens over time. Thank you for your attendance, and that concludes our presentation. For any further questions, please visit us at our booth or visit us online at www.optilab.com.
Thank you very much, and also thank you for the advice that there is booth for the companies, right, where we can have much more opportunities to get things discussed.